Welcome back. I'm talking to Andrew Johnson about cold fusion. Now, before we go on and explore cold fusion in more detail, we really, I think, first need to just explain why these things we think have been suppressed. Energy technologies which would threaten the established industries of coal, oil, gas and nuclear, because 90% of the world's energy comes from those sources. I mean, we can all look at wind farms and other tidal, what have you. They haven't really made any dint in the amount of energy that's produced. There were still 90% still comes from things which are dug out of the ground, and there are huge industries. Millions of people are employed, and millions of people have become extremely rich because of the oil, coal, and gas, nuclear industries. And I'm just going to read this little extract from my book, where I'm trying to illustrate the problem of getting over this hill into new energy technologies. That there's a large mountain ahead of us in our journey of progress, and if we climb over the mountain, on the other side there is a much better place to live. However, there are people on the side of this mountain blocking the way, because it is not in their interest for us to go there, and they are stopping us by using every way they can from going further up the mountain. The people blocking us are the oil cartels. The mountain is the changes we need to endure to redesign our energy systems, and the pastures over the hill are free energy. So it's a lot of people talk about the energy cover-up, Andrew, and you're quite suspicious of some of the groups which claim to be researching new energy technologies. Just tell us about that.
Yeah, absolutely. And I think, there's a mixture of things at work here. We've got, as you say, the vested corporate interests trying to keep this under wraps and to a point where it doesn't get into use. Mm-hmm. But then we've also got disbelief in the science community, which you can see in the cold fusion story very clearly. Mm-hmm. That you could never get energy from a source which doesn't require any fuel. That's what we're looking at. We're looking at a system of getting energy which doesn't require any fuel or very little fuel, because all of the energy sources that we use now, if they're not, apart from solar of course, and windmills and stuff, and wind turbines, they need a source of fuel, some type of combustible material or nuclear material and so on. And that's where all the money lies, because we're forever filling up, digging more out of the ground, prospecting. That's a whole big business money machine that, very large amount of economies are sort of focused around that.
What we're talking about basically is a box, perhaps not much bigger than a shoebox, that you could disconnect your house from the mains and plug it into a shoebox that will keep your house going with electricity forever, and will heat your water, and will also, you stick one in your car and it'll power your car, and you never have to put anything in it.
Right.
And you need to realize that all of these energies that we use, they're all metered. So at the petrol pump, it comes out and it's read on a meter. Your house has a gas meter, it has an electric meter. And because it's metered, because there's stuff flowing in, they can then get you financially. So they can charge you and they can control you. So having free energy would just be huge. It would be a paradigm shift on the earth if people did not have to be attached to various grids in order to get their energy consumption.
Correct. And what happened with cold fusion, if we were to summarize the story, and I recommend a very good book by Dr. Eugene Mallove, who we're going to talk more about him in the coming minutes, but Fire from Ice by Dr. Eugene Mallove, that documents a story of cold fusion. And I think you can see from that book that in 1989, when Pons and Fleischmann came out with this research, basically saying, well, look, guys, we seem to be getting out more energy than we're putting in, perhaps because of this nuclear process. Mm-hmm. And it was Stephen E. Jones who actually coined the term cold fusion, the same Stephen E. Jones who's the 9/11 researcher who sort of appeared on the scene in 2005, the year after Mallove was murdered. So we can directly see, we've talked about the tritium that was found in the dust. We can directly see that there's a connection between the evidence in 9/11 to energy and also in some of the personnel in the truth movement, because Stephen E. Jones actually worked at Los Alamos National Laboratories for a while, or he did consultancy work for them, and he also worked for the Department of Energy. And what happened when Pons and Fleischmann came out with this research is they had sufficient scientific evidence at the time to show people that their process really did work.
This was in 1989.
In 1989.
So was Mallove involved with Pons and Fleischmann at that point?
No, not directly, because what he essentially did was he was reviewing their research for Massachusetts Institute of Technology, because he needed to write about it for their science publications. And he, in this clip that we're going to play, he talks about this magazine called, I think it's called Technology Review, that he was going to do an article about cold fusion, basically saying that yes, it did appear that this was very important research and needed to be developed. And Mallove's boss, and Hermann Feschbach was his name, basically stopped the article from being published, his favourable article. And at that point, Mallove in 1989, or around about that time, maybe 1990, decided that he would leave his post at Massachusetts Institute of Technology, because he discovered that in their own reproduction of Pons and Fleischmann's experiments, they'd massaged the data to hide the core central claim of excess heat. In other words, Massachusetts Institute of Technology reproduced Pons and Fleischmann's experiments. They got similar results. They got a small amount of excess heat, in other words, more energy out than they put in. But then they sort of massaged the figures to hide this. And Mallove found out that's what they'd done with his own expertise in looking at the data. And then he thought, right, if you're going to do this experiment, and then you've obviously corrupted the science, and then he left.
So he was aware of some kind of fiddling of the data and cover up.
Correct.
Right. Now we're going to look at a clip which just explains a little bit of the science behind it, and one of the key scientists in this clip. Just remind me of his name, Andrew.
Well, you'll see Martin Fleischmann. He's obviously the guy that came out with Pons initially. And then after that, you'll see a chap called John Bockris from Texas A&M University, who's described as a world-class electrochemist.
He does say that they observed transmutation.
Correct.
So
that's the other key factor. Right. If you listen to this clip, you'll hear him describing a process of transmutation, which he says in the clip. It's the process of turning one element into another. In other words, you're getting, for example, palladium turned into silver.
And I think you mentioned copper as well.
Yeah, and copper as well.
Which he says, he uses the word which they're not allowed to use, which is alchemy.
Alchemy, correct.
Yeah. So one would presume, if one was to do that, to turn one metal into another, there would be some mass left over, which was the source of the energy. Correct.
So again, this transmutation, I mean, you get essentially in a nuclear reactor, you sort of get a form of transmutation because of the fission, where you get a uranium nucleus splitting up and giving strontium and cesium and all these other elements, which they would never have been there in the original material. They're only there after the nuclear reaction has taken place. They're new elements that have been produced within that nuclear reaction. That's why it's nuclear.
So this clip we're going to watch now, Andrew, just tell us when this was made and who's produced it.
This was from a documentary which you can watch online. I recommend people watch this thing. You can pick it up on YouTube. It's called Fire from Water, and it was made in 1999 by, and Eugene Mallove was involved as the producer of this documentary. And it contains interviews with some of the leading lights in the cold fusion or low energy nuclear reactions research.
Water itself is quite a mysterious and powerful substance. Given enough time, it can erode steel and rock. It is composed of hydrogen and oxygen, two of the most reactive elements on Earth. Science has also known for over 200 years how to extract hydrogen and oxygen gas from water through the process of electrolysis. It was from this field of electrochemistry and not nuclear physics that there emerged a revolutionary idea of a new kind of fire from water. In the 1980s, Fleischmann and Pons used their own money to conduct experiments for 5 years. They passed a current through an electrochemical cell containing heavy water, or deuterium oxide. One of the electrodes, the negatively charged cathode, was made of the precious metal palladium. The electrical current separated individual deuterium nuclei, or deuterons, from the heavy water and forced them to pack tightly into the palladium cathode. What happened next inside the palladium at the atomic level remains a mystery and became the subject of intense debate. Whether it was actual nuclear fusion or some other as yet unknown phenomenon, the result produced far more excess heat energy than any known chemical reaction. Why is such a phenomenon so astonishing? Why did it provoke such outrage in the physics community? To most classically trained physicists, the concept of low-level nuclear reactions producing significant heat energy was inconceivable.
It was a very unfortunate time to make such an announcement for various political reasons, really. The situation in the United States, the situation with regard to the program in hot fusion. So that was against it. But also, of course, was the fact that we were not ready to make such an announcement. The criticism of pathological science is one which has quite frequently been leveled at unusual investigations, which admittedly sometimes are at fault. However, there is also the situation that people will criticize a field long after they should really have given up. And that is pathological criticism. They just get trapped in a situation. They have made a criticism. They have to maintain that criticism against all the evidence.
At Texas A&M, a group led by Professor John Bockris, who is widely regarded as one of the world's greatest electrochemists, reported finding the hydrogen isotope tritium, a key signature that some unusual nuclear reaction was going on.
The first thing was this thing called tritium, which is a sub-form of hydrogen which should not exist except in extremely tiny quantities. We found that by working these cells of Fleischmann and Pons containing lithium hydroxide and deuterium oxide, that we could produce this tritium in great abundance. Let's say at 10,000 times more than it ought to be there, as it were. And let me stress that we couldn't do it every time, but about one result in 5 or one result in 4, and eventually we worked up to 2 results out of 3. We could produce tritium. That was the first thing, and in a way it was the first clear proof of the phenomenon.
At Texas A&M, Bockris's group found themselves under attack. Science magazine writer Gary Taubes wrote a stinging article that insinuated that someone in the group had spiked the samples with tritium. Although unfounded and eventually proved untrue, the allegation effectively dampened Bockris's remarkable claims.
Well, I was 69 years old at that time, and I took the attitude, suppose they fire me, right? It doesn't really matter. I'd had my career. The worst they could do would be to say, go, your tenure is withdrawn. And therefore I wasn't frightened. And I went on saying the truth and publishing what we'd got. But finally the university revolted against this. And they set up an inquiry, as they called it, rather sinisterly. The accusation was that I had carried out misconduct of research, you see, that I shouldn't have worked on these things. And they decided that the accusations were totally groundless, and they published all this. But then they started all again about 6 months later, and they had another committee. It was this time, when my lawyers asked the university what the second inquiry was about, they were told, it's an ad hoc committee. What's that? We have nothing further to tell you. And so this went on for 11 months of constant meetings and inquiries and so on. And I'm quite sure that they were trying to find an excuse to end my tenure, you see. Finally they came out okay. I mean, they gave me another letter. I'd had the letter of complete exoneration. This time it said that they had spent this 11 months and had found that I had never done anything, the phrase used were, that contravened the rules of procedure of this university, or something rather formal and stuffy like that. But I think the main part was that I had done work which was against the paradigm, and that was what they were really upset about. You know, people said that they'd been to other universities and people had laughed at it and said, what the heck are you doing, trying to disprove the laws of nuclear physics? And of course that's exactly what we were doing, and succeeding, you see.
Even though positive results were still coming in, The Department of Energy's negative report effectively killed congressional funding in the United States. Fleischmann and Pons later packed their bags and left for France to carry on private research sponsored by the Toyota Corporation.
By 1992, we had video recordings of intense energy release. By the summer of 1994, we had demonstrated sustained energy release. That, of course, if you say you wish to make this into a device, required further research. And we were always working on a time frame of trying to get to that point by about the year 2000. And I think that if the resources had been available, we would have got to that particular point, probably before the year 2000. But this did not happen.
Yet as early as 1992, cold fusion experimenters began reporting unusual appearances of trace amounts of different metals such as copper, silver, chromium, and zinc when examining their spent cells. Rechecking for possible contamination, scientists like Bacchus and Miley confirmed that indeed new metals and isotopes were being formed, transmuted, during the process which produces excess heat.
Kevin Wolf made many measurements of tritium. Then he got some even more astonishing results as early as '92, which were these transmutational results, the metal forming another metal inside the electrode, you see, which was super anti-paradigm. You know, there's that dreadful word alchemy, which we mustn't use, but it was a form of that in a way, that was creating new metals, you see.
In Japan, Tadayoshi Omori and Tadahiko Mizuno at Hokkaido University have produced volumes of data under rigorously designed experiments showing the production of metals ranging from iron to platinum and beyond. The Omori cell using a tungsten cathode has consistently produced excess energy along with measurable amounts of transmuted metals.
Very interesting. Now, my question would be, okay, that was in 1999, and these scientists definitely claim that there's something going on, and that people were trying to discredit them. So what's happened since then?
Well, there's been bits and pieces of rumblings. For example, I think it was in 2003 that there was some research published. I forget exactly where it was, but I think it was the body that had done the research was the Naval Research Laboratory, and they produced like an updated report about some of the aspects of cold fusion. And I believe part of their rationale was that they were worried that groups could use the cold fusion process to do enrichment of uranium. In other words, they could, use a slightly different cold fusion process to produce material to make a nuclear bomb. I think there was some rumblings about that, and that's why they reinvestigated cold fusion.
Right. So do you think that's just an excuse to cover it up, or?
Partly, but their experiments, did produce a positive result. They did say that there was something going on. They didn't debunk it. They didn't sort of totally endorse it either, but they sort of said that yes, there is something going on here which needs further research.
So am I right in thinking that there are groups now investigating low-energy nuclear reactions?
Yes, but they're sort of quite low-key, low-profile. I think some of them are doing it privately on their own time. I don't think there are maybe one or two projects which are being funded by postgraduate research sort of organisations and this sort of thing. But in the main, you're not going to find anything. There was another thing published in about 2008, the CBS did a 60-minute special. There's a chap called Michael McCoubrey who works for SRI, Stanford Research Institute. He's also been doing ongoing experiments in cold fusion research.
Right. All right, Andrew, thanks very much. And we'll be talking more about cold fusion and Eugene Mallove after this.